Hello everyone. In this video, we are going to discuss about how to derive canonical sum of products, that is SOP, using algebraic method. So, you will be given an expression, you have to convert it into an canonical sum of products. Now, you can see an example, convert x dash y plus x dash z dash the whole dash into canonical sum of products form. So, this is a question which will be asked in board exams. So, how to convert this? So, you are going to see the rules first. So, rule 1, simplify the given expression using appropriate theorems and rules. So, you are going to first simplify these. Okay. So, here you can see that whole dash, it can be simplified using De Morgan's theorem and few other theorems, and then you are going to do the next step. So, here you can see the expression x dash y plus x dash z dash the whole dash, okay, which can be converted using De Morgan's theorem, so that you will get x plus y dash x plus z. So, you may be wondering how you got this. We already discussed about De Morgan's theorem, the previous videos, you can go through that. And one more hint here is, when you have whole dash, you can know that everything will be inverse. So, you can see x dash will become x and y will become y dash, and you got a dot operator which will become plus. You can see here x plus y dash. Same way, this plus will become dot, and here you can see x dash dot y z dash, it becomes x plus z. Okay. So, this is how you can identify. So, it is just a small tip where you can know it has been converted using De Morgan's laws. Next is using distributive law, okay, you can convert this expression into this x plus y dash z. Okay. So, this is just a reverse process. Normally, you will have x plus y dash z equal to x plus y dash into x plus z. Okay. So, the same thing can be written in reverse order. Okay, you will get this expression. Now, you have three variables expression. The product term must have all three variables. So, you should convert it into a canonical sum of product. So, you should have product term, okay, which should have three variables, okay, because it is given as per the expression, you got three variables here. So, now you are going to make it. So, rule 2, whenever a literal is missing, multiply the term with missing variable plus missing variable the complement, missing variable complement. So, when you read this, you may not be able to understand, but when you see the expression, you may understand. So, this is the expression what you got, x plus y dash z is the expression. So, here you can see three variables. So, this is one term, this is the second term. So, in the first term, y and z is missing, and here the second term x is missing. So, here what you can do is you are going to multiply the term with the missing variable y plus y dash, and then z plus z dash, that is the first expression, first term. Second term x is missing, so you can put x plus x dash, okay, into y dash z. So, this is the rule number 2, missing variable plus missing variable dash, that is complement, okay, should be multiplied with the term. Now, when you multiply this, this term you will get x into y, okay, x into y dash. So, this is what you got from this term, and then the remaining term you can write it as it is, z plus z dash, plus here you can multiply the x with y dash z. So, you got x y dash z plus x dash y dash z. So, you are going to get that term. Now, you got another product term here. So, you are going to multiply this. So, what you will get is, so before doing that, you can put z in front and write the terms separately. So, z into this term, again plus z dash into this term. So, when you write it separately, you can always multiply it in future, right. Now, when you multiply z here, z into x y. So, x y z, then you got x y dash z. So, you got the second term here, and then you got z dash here, x y z dash plus x y dash z dash. So, you got it here, right, then remaining terms. Now, this is what you got after implying the rule 2. Now, rule 3, remove the duplicate terms. So, you got some duplicate terms here. So, first you will identify which are the duplicate terms available here. So, first term is not repeated anywhere. Second term you can see x y dash z is been repeated here. You can see here x y dash z. So, it is repeated twice. Remaining terms it is not repeated. So what you are going to do is you are going to remove that duplicate term. So you are going to cancel and you are going to keep only one. You are going to remove the duplicate one and keep only one and write the term, that's the remaining term, we call it as a canonical expression. So this is the desired canonical sum of products form. It can also be represented by the following shorthand notation. So you got another notation called shorthand notation. We will show you that. So this is what you call it as a shorthand notation. You can also call it as cardinal form. Okay. So the previous one, the whole expression, you call it as canonical form, and with the numbers, min terms, you call it as cardinal form. Okay. So you can say f equal to summation of, and then within parenthesis you write 1, 4, 5, 6, 7. You might be wondering how you got this. We will be explaining you. Okay. So here you are going to see how to convert the shorthand notation to min terms, right? So you already seen the shorthand notation. You might be wondering how you got that shorthand notation. So this is the solution here. Rule 1, find binary equivalent of the decimal subscript. Example, for M6 the subscript is 6. Okay, so for that subscript value is 6 here. The binary equivalent for 6 is 110. So you have to convert this decimal value into binary. So 110 is the binary value. Now rule 2, for every ones write the variable as it is, and for zeros write the variable complemented form. So for example, for 110 you can write the variables as, so for 1 you are going to write the variable as it is, so x and y, and then for 0 you are going to write the complemented one z dash. Okay, is the min term for M6. So you got the expression now for the number. Same way you are going to do it for an example. Here you can see a question given, convert the following 3 input function f denoted by the expression f equal to summation of 0, 1, 2, 5 into its canonical sum of products form. So cardinal form is given here. You are going to convert it into canonical form. In exams they may give you the canonical form and they will ask you to convert it to cardinal form. We just saw that. You have to just write the numbers, okay, min term numbers, and write it as a cardinal form. Now here cardinal form is given, you are going to convert it into canonical form. So you are going to see how it is. The solution, we can take 3 inputs as x, y, z. You can take any other variables. Generally we will take x, y, z, and write these numbers 0, m0 plus m1 plus m2 plus m5. So these are the min terms you got. So you are going to add it up, right? Okay, because it is sum of product form. Now you are going to find the expression for each term. So m0, it is 0, 0, 0. So you are going to write it as x dash, y dash, z dash, because all are 0. So you are going to write the complemented version of the variables. Here m1 is 0, 0, 1. So x dash, y dash, z, and then m2 is 0, 1, 0. So it is x dash, y, z dash, and for m5 it is 1, 0, 1. So it is x, y dash, z. So here you have to remember, you have to convert these decimal values 0, 1, 5 and 2 and 5 into its binary form. So once you convert it into binary form, you have to replace it with the variables, complemented or uncomplemented. So you will get the expression by combining all these expression, whatever terms you got, you will get the canonical SOP form of the expression. So you can see that all that being combined using a plus operator. Okay. So hope you understood this video. We will meet you in the next video. Till then, thank you.